Hello and welcome to the Analysis Mason podcast. My name is Christopher Baugh. I am a partner here at Analysis Mason and head of our space research practice. Delighted to welcome you today to hear about a topic that is very important in the space industry and telecom as well, which is new constellations. And the two we focus on today are going to be Amazon Leo and TeraWave, two very high profile constellations, one from Amazon, one from Blue Origin, and the impact that they have. But today, I'm delighted to welcome one of my colleagues, Prachi Kawadi, who is the head of our satellite capacity program and our research there. So Prachi, senior analyst, welcome to the podcast today.
Thank you, Chris.
So Starlink, it's a household name. They are taking the world by storm as they've done from their start to now, and growing by the day. Consumer broadband, maritime aviation, backhaul, government, all things, and now direct to device and onwards. But we have these new constellations coming. So big ones, very high profile, deep pockets behind them. So the why question becomes, is there enough market, but generally speaking, what's driving this introduction? What shifts can you point to, Prachi?
There is a lot of thing that we're hearing about in the industry. It's more to do with AI, which is leading to the need for compute, data centers, etc. With all of this increase in data traffic itself, there is need for connectivity to be available at the faster data rates compared to what's available today. So even though there are terrestrial options, when we are thinking about it more in terms of a remote connectivity as well, offsite, offshore, etc. So in those cases, that's where the value add comes in for the satellite communications piece. And given that more and scalable operations are coming across different enterprises, and the need for the data to be as closer to the site itself, where the edge compute element comes in. So because of that, there is a significant need or a bottleneck to have the connectivity, which is much faster than we have today.
Interesting. So it goes so far beyond connectivity, which is everyone thinks of consumer broadband. My mother has Starlink. I know many people who have it. It's kind of the nature of the beast. If you need it, you have to have it. But you're thinking about these new constellations as really much, much more. We mentioned AI, data centers, enhanced connectivity, enterprise, sort of cloud connectivity type things. So that's an interesting, and Starlink, full disclosure, has announced their own million satellite orbital data center constellation, which I think will have its challenges from launch capacity and also timelines. But interesting, right? Everyone's going down that road now. But let's focus on Amazon Leo. And Amazon Leo this year has some milestones to meet. They've just announced another big constellation shell. They were approved by the FCC to deploy. But from your side, let's talk about their strategy, their positioning going forward. It's not a consumer-only approach, I know, but what is it that they're going to do potentially, maybe something different than Starlink as well?
I think what they're trying to do at the moment is trying to establish a key differentiator. So given that Starlink is mass market, a consumer focused, significant adoption there. So now there has to be a different entry strategy. And in this case, it would be addressing the enterprise first. Now, what makes this a unique proposition for them is not just the assets that they have in space, but it's more to do with what they have additional capabilities on the ground. It's the direct integration with AWS. It's the private networking capability that they can offer, the co-location services, the level of SLAs that are being assured. So it's not just the availability of time SLAs that they're offering. They are offering committed information rates, additional level of security, etc. That these elements actually bring in that additional layer of services that can be stacked together along with the connectivity itself. Now, what happens when these things come together is it becomes a much more stronger value proposition and end-to-end solution rather than just being a data pipe positioning in the market. And that changes everything when it comes to addressing the enterprise customers.
Well, it's interesting, Praj, because it is a very different approach, right? I guess, so to speak. But Starlink, I'm sure, I'm just getting ahead of the game here. They launch. I can't imagine Starlink will sit idly by, allowing Amazon Leo to have unique. I mean, it's going to be. It sounds, again, the dynamic is changing almost daily, but this today, when they do launch, will be a competitive differentiation. But I imagine over time, again, there's opportunistic and heavy strategies coming from Starlinks. Would you agree? I mean, it's kind of that piece of how unique and how sort of revolutionary will this approach be, and how much of a gap is there between Starlink and an Amazon Leo at launch, given what you just said?
So at the moment, Starlink offers the uptime SLAs. There are no other SLAs assured beyond that, but they do address on case to case basis the requirements for particular enterprises at time. But then the assurances are not there, which kind of enables the other resellers to provide a service on top of the current Starlink availability to the enterprise customers. Now, at the moment, if you look at the data rates provided by Starlink, they are 200 Mbps on maximum, and then it varies depending on region and the number of users, of course. But then Starlink is going to be launching from Jan to June. The new set of satellites, which is the V3, 1 Gbps in terms of the data rates that they have. When comparing it to the Amazon Leo, this is what they're going to have from the get go. They have three different antennas to address. The Nano one is the 100 Mbps one, then the Pro is up to 400 Mbps speeds, and then they have the Ultra, which is up to 1 Gbps download and 400 Mbps upload. So this is like right the entry point matches exactly where Starlink is adding capabilities now.
So it's kind of Starlink has early market entry positioning, so they grow. They have quite a bit of revenue at the moment, but when Amazon Leo launches, they're going to be competitive, very competitive, with high data rates and all of the rest. So it's kind of, even though Starlink launched early, they're going to need to catch up, or they are going to be catching up. So it's kind of each side rising higher dependent on competitive positioning. So very interesting. I mean, we talk about Amazon Leo today as if they're available. They only have a few hundred satellites up. So we do need a milestone. Of course, we had a launch just with Ariane's boss just yesterday. So a lot happening on that front. So very interesting dynamic there, but let's talk about something somewhat different, maybe somewhat the same in some areas, which is TeraWave from Blue Origin, related because Blue Origin is somewhat related to all of this, loosely or not. That caught the industry, I think, many by surprise when it was announced, because here's a launch company now going into spacecraft sort of operations, constellation deployment, and kind of closing the loop there. Can you talk a bit about TeraWave? What is it? How is it different or unique? And what is their positioning as well in this space beyond Starlink?
So TeraWave is uniquely just designed to address the enterprise customers. They're focusing on enterprise data centers, government customers. Those are their core customers, limiting the strategy only to target 100K customers, which kind of gives them straying away from the mass market strategy that currently Starlink has. The reason being their architecture itself. Now, they are using QNV bands in the RF, having about 5,280 satellites in LEO and 128 satellites in MEO. So the MEO satellites have the optical intersatellite links, which act as the backbone with 60 bps or data rates. And then the ones where the QV band, it's more of a symmetrical type. So upload, download at 144 Gbps, which is currently a step up, like a significant step up when we compare to 1 Gbps data rates that Amazon Leo or Starlink is currently planning to launch. But what this means is when it comes to the QB bands, specifically, there is a need for a very narrow band availability, and it works well with only fixed sites. That's the reason their positioning is very unique and tailored to where the security element is required significantly or is crucial.
Okay, so very different approach. Some similarities in terms of, we see your government or customer types, government, data centers, large enterprise. I mean, these are big bandwidth. These are big beams, big amount of bandwidth. This is not for the small user. So that's an interesting approach. And I think I saw somewhere that they're limited in terms of the number of subscribers, number of sites that they can go after. So 100,000, I think I saw the number. So it's again, proving that there is a business case for that many sites. It has to be high bandwidth, high value per site. So it's kind of an interesting high level approach to things, would you say?
Yes, agree. What happens is if we are thinking these sites to be, for example, in case of data centers, now each data center would be not going for like gigabytes of data. It would be petabytes of data that's transported, and that changes the equation of per site the revenue that can be achieved, and the possibility with the speeds that are available. For example, thinking of it more from the perspective, if we are comparing the current terrestrial capabilities, it's somewhere 1.5 Gbps on average, but here it's 60 bps we're talking about. So now the proposition changes. You have a significantly higher value, faster data pipeline that's available at this point, and then it becomes much more competitive even compared to terrestrial at that point. So that changes what the cloud service providers or data center operators would look at in terms of connectivity towards satellite.
Okay. Okay. Excellent. Now let's shift gears a little bit. Talk timing because I mentioned Amazon Leo. We hope the industry hopes will be commercially available this year at some point. TeraWave we're a few years off, just because the time to build and launch and everything. Indeed, but I wanted the late market entry point. So Starlink has been in the market for years, and they've grown, keep compound growth every year. They keep growing and expanding what they're doing. Amazon Leo, everyone's late after that. The question we often get from clients, really one of the leading questions is the market big enough? Does it matter? We certainly need more, but how will that impact their market entry? Is there enough market? How will that shift the dynamic in terms of Amazon Leo later this year and then TeraWave and others? Those are just two of the high profile ones. We know there are many, many satellites coming from others too. Can you talk a little about the timing? Is that going to limit Amazon Leo? Will it? TeraWave is still a few years off. Will others iterate faster in the interim to that, or how will this all play out from a deployment perspective?
From deployment perspective, at the moment, Amazon Leo is targeting for service rollout this year. They still need to deploy, so they need at least 500 plus satellites to be deployed just to provide the service itself. They're currently about 200. So, assuming even if they meet the initial timeline that they had mid-year, I don't think that's the timeline they would be able to meet. It would be somewhere towards the end of the year where actual service rollout would happen. And in cases, the coverage starting point is 26 countries for them. So give thinking of it from two different perspectives. So on the consumer side, given that Starlink has well-established customer base, it becomes much more of a challenge because of the late entry for Amazon Leo. So there they are acting more as a challenger. But then if we are looking at it from the enterprise perspective, Amazon Leo does have enterprise customers. This is more of adding or upsell to the current services that they have. And so it's much easier entry point to just focus on the enterprise customers for them at the beginning. But then it has to be very tailored, the approach. It has to be phased well out, focus on what the customer really needs.
Sure, absolutely. And a very different thing than just mass consumer approach to things, which is, again, proven well for Starlink, but not the approach here. So you mentioned another question we get from clients a lot with some of these new constellations. We talked about data centers. You've said a few times, orbital data centers, even connecting data centers on the ground via space, and using AI sort of to manage traffic, to manage compute, and everything else. Why does that? I imagine that's going to be a very important theme going forward with all of this. Would you agree?
Yeah, so we can say the next best currency would be compute and power. Thinking of it in terms of global macroeconomic perspective. So tying it back to space, there is a bottleneck that we will see just because the pace at which the data is multiplying significantly, where the connectivity will become a limiting factor. If there is no seamless connectivity, it will be a challenge. That's where both these constellations come in, where they can address that connectivity elements at the time. The other things is there is increased adoption of cloud services. There is focused on edge computing as well overall. So because of these, the need for data centers, because of the compute storage needs, is also increasing. So indirectly, that feeds into the overall demand as well.
Okay, well, that's we'll be covering. We have covered, and we'll cover quite a bit more on data centers and that intersection with space. And I mentioned off the top, Starlink or SpaceX, 1 million satellites with orbital data centers, and then Star Cloud, tens of thousands of. They're just it's kind of the Wild West right now for all of it. But you have real tangible constellations launching this year, and Amazon is a household name. AWS, it's kind of the nature of where we're headed with it and then onwards. So very interesting time. So, Prajak, the last question I'm going to bring about, we've covered a lot, and we could go on for many, many more minutes, hours with this topic, but I want to focus on the future instead of the closing bits. Maybe some of the challenges, or kind of what are the takeaways slash challenges you'd highlight with all of this? Because there's a lot of exuberance around it, a lot of interest, excitement. Some on, if you've been in the space industry a long time and you're selling capacity, operators and others, is a bit of concern as well, given what these deep pocketed constellations represent. So, what key takeaway, given these two constellations and what we expect in the next year and onwards in space?
Right. So I'll start with the challenges first. So mainly there are some optimistic timelines for deployment of the constellations. So the launch cadence can be a challenge. The pace at where the satellite manufacturing capability itself, the volume production can be a challenge because of the stakeholders involved. The overall cost, because it's 3,000 plus satellites on both the sides. So the overall capex is significantly higher. Moving towards mainly focusing on the TeraWave, the optical tech that they are going after, not developed yet. Current tech is available at somewhere around 100 Gbps range. There is development towards 1 Gbps like embryonics, etc. Then 6 Gbps is significant step up. Bridging that gap would be very critical and will be time consuming. So 2027 timeline seems really optimistic in that scenario. Same with the development of the QV band related tech, especially there are propagation challenges, scintillation, atmospheric attenuation. There is additional element of management of sites itself that's involved, the complexity that comes working with the band. So that technology readiness level needs to be at a particular place for the full service deployment. Again, the 2027 timeline seems really optimistic. The key takeaway would be there is shift in the industry where the focus is more becoming like how integrated the satellite communications will be with the existing digital infrastructure rather than just being the backup link that it has always been in many cases, especially from the
Okay,
enterprise
so
perspective.
absolutely, absolutely. I think to kind of paraphrase a little bit of what you said, it's like everything in space, take timelines with, as they say, a grain of salt. It's going to be things shift to the right always in space. And I personally would highlight one of the big things, which is just launch capacity with all of these constellations and timing. We, as an industry, just do not have enough launch capacity and capability. And it's very hard to do, and to do with a regular cadence and reliability. So that's one of the things, minus all of the tech, of course, optical you mentioned, those are huge, huge challenges. And I think things to overcome, which again, the money is behind it. And I'm sure we'll see that happen at some point. But opportunity is clear. I think this intersection, I agree with you, Prachi, this intersection we're in the midst of right now, and it is happening fast. Everything from just integration of the space into the terrestrial network, applications, core, everything. It is happening now. So it's a very exciting time for space. But with that, that'll end us. We're over time. But thank you, Prachi. Very good insights today. So there is more content on this topic. We have a number of space programs that cover these topics, including some that Prachi runs today. So have a look at those on the Analysis Mason website. And if you love the podcast, if you like it, please do subscribe. We're going to do many more of these on many more space topics in the near term. So with that, thank you, Prachi.
Thank you, Chris. Thanks, everyone.